Hello and welcome to a journey deep inside our planet. Today we're diving into the fascinating world of Earth's tectonic plates. These massive slabs of rock are constantly moving and interacting, shaping the world we know. From towering mountain ranges to deep ocean trenches, tectonic plates are the architects of our planet's dramatic landscapes. They are responsible for earthquakes, volcanoes, and even the very air we breathe. Join me as we explore the science behind these powerful forces and discover how they have shaped Earth's history and continue to influence our lives today. Get ready to be amazed by the incredible power hidden beneath our feet. Imagine Earth's surface as a giant jigsaw puzzle, but instead of cardboard, it's made of massive slabs of rock called tectonic plates. These plates are the building blocks of our planet's surface, and they play a crucial role in shaping the world we live in. These plates fit together like puzzle pieces, forming the Earth's lithosphere, the planet's rigid outer shell. The lithosphere is divided into several pieces, much like a cracked eggshell, and these pieces are constantly in motion. There are 7 major tectonic plates and several smaller ones. The major plates include the Pacific Plate, North American Plate, Eurasian Plate, African Plate, Antarctic Plate, Indo-Australian Plate, and the South American Plate. Each of these plates has its own unique characteristics and geological features. These plates are not static, they constantly move and interact with each other. This movement is a slow but powerful process that shapes the Earth's surface over time. The interactions between these plates can lead to the formation of mountains, earthquakes, and volcanic activity. This movement is driven by the intense heat deep within the Earth's core. The heat causes the semi-fluid asthenosphere beneath the lithosphere to flow, which in turn causes the tectonic plates to move. This process is known as mantle convection. The plates move slowly at a rate of a few centimeters per year, about the same speed as your fingernails grow. While this may seem insignificant on a human time scale, over geological time it results in dramatic changes. But over millions of years, even this slow movement can cause significant changes to the Earth's surface. For example, the Himalayas, the tallest mountain range in the world, were formed by the collision of the Indian Plate and the Eurasian Plate. Similarly, the San Andreas Fault in California is a result of the Pacific Plate sliding past the North American Plate. Tectonic plates interact at their boundaries, which can be classified into 3 main types: divergent, convergent, and transform boundaries. At divergent boundaries, plates move apart from each other, creating new crust as magma rises to the surface. At convergent boundaries, plates move towards each other, often causing one plate to be forced beneath another in a process called subduction. Transform boundaries occur where plates slide past each other horizontally. The movement of tectonic plates has a profound impact on human life. Earthquakes and volcanic eruptions, which are direct results of tectonic activity, can cause widespread destruction and loss of life. Understanding the dynamics of tectonic plates is crucial for predicting and mitigating the effects of these natural disasters. As we look to the future, the movement of tectonic plates will continue to shape our planet. Over millions of years, continents will drift, new mountains will rise, and old ones will erode away. The Earth's surface is in a constant state of flux, driven by the relentless movement of its tectonic plates. By studying these processes, we gain a deeper understanding of our planet's past, present, and future. The boundaries where tectonic plates meet are dynamic areas, constantly reshaping the Earth's surface. Here, incredible geological forces are at work, driving the movement of continents and the formation of new geological features. There are 3 main types of plate boundaries: divergent, convergent, and transform, each playing a unique role in the Earth's geological processes. At divergent boundaries, tectonic plates move apart from each other, creating new crust in the process. This process often occurs in the middle of oceans, forming mid-ocean ridges, which are underwater mountain ranges that span thousands of kilometers. As magma rises from the mantle to fill the gap created by the separating plates, it cools and solidifies, creating new oceanic crust. This continuous process adds new material to the ocean floor, gradually pushing older crust away from the ridge. Convergent boundaries, on the other hand, are regions where tectonic plates collide with each other. When an oceanic plate collides with a continental plate, the denser oceanic plate is forced beneath the lighter continental plate in a process known as subduction. This process is responsible for some of the most dramatic geological features on Earth. Subduction zones create deep ocean trenches, some of the deepest parts of the ocean, and volcanic arcs, which are chains of volcanoes that form on the overriding plate. Transform boundaries occur where tectonic plates slide past each other horizontally. Unlike divergent and convergent boundaries, transform boundaries do not create or destroy crust, but instead, they accommodate the horizontal movement of plates. The friction between the sliding plates at transform boundaries can cause earthquakes. These earthquakes can be minor, causing little to no damage, or they can be major, resulting in devastating consequences for the regions affected. The San Andreas Fault in California is one of the most well-known examples of a transform boundary. This fault is responsible for many of the earthquakes that occur in the region, highlighting the immense power and potential danger of these geological features. The Earth's surface is divided into several large and small tectonic plates, each moving at a different rate and in different directions. The interactions between these plates shape the planet's surface, creating mountains, ocean basins, and other geological features. Volcanic eruptions at convergent boundaries can be particularly explosive, as the subducting plate melts and forms magma that rises to the surface. These eruptions can have significant impacts on the environment and human populations. Earthquakes, especially those at transform boundaries, can cause widespread destruction, collapsing buildings and infrastructure, and leading to loss of life. Understanding these boundaries helps scientists predict and mitigate the impacts of such natural disasters. The Himalayas, the tallest mountain range in the world, were formed by the collision of the Indian and Eurasian plates at a convergent boundary. This ongoing collision continues to push the mountains higher each year. Deep-sea exploration of mid-ocean ridges has revealed a diverse and unique ecosystem thriving in these extreme environments, showcasing the incredible adaptability of life on Earth. Scientists continue to study tectonic activity to better understand the processes that shape our planet and to develop methods to predict and prepare for natural disasters. The study of tectonic plates and their boundaries is crucial for understanding the dynamic nature of our planet. It provides insights into past geological events and helps us prepare for future changes. As we continue to explore and understand these powerful forces, we gain a deeper appreciation for the ever-changing nature of our planet and the incredible processes that have shaped it over millions of years. Section 4. Unraveling the secrets of plate tectonics. The theory of plate tectonics revolutionized our understanding of Earth's geology. Before this theory was widely accepted, scientists had various ideas about how the Earth's surface was formed and changed over time. However, none of these ideas could fully explain the dynamic nature of our planet's surface. The introduction of plate tectonics provided a comprehensive framework that could account for a wide range of geological phenomena. It explains how continents have drifted across the globe over millions of years, how mountain ranges are formed, and why earthquakes and volcanoes occur in specific locations. For instance, the Himalayas were formed by the collision of the Indian plate with the Eurasian plate, a process that continues to this day. Similarly, the Pacific Ring of Fire is a direct result of tectonic activity where multiple plates interact, leading to frequent earthquakes and volcanic eruptions. Evidence supporting plate tectonics comes from various sources, including the fit of the continents, the distribution of fossils and rock types on different continents, and the magnetic stripes found on the ocean floor. The jigsaw-like fit of the coastlines of South America and Africa was one of the first clues that led scientists to consider the possibility of continental drift. Additionally, similar fossils and rock formations found on continents now separated by vast oceans further supported this idea. The magnetic stripes on the ocean floor are particularly compelling evidence. These stripes are symmetrical on either side of mid-ocean ridges, indicating that new crust is continuously being formed and pushed outward. This process, known as seafloor spreading, was a critical piece of evidence that helped confirm the theory of plate tectonics. These stripes are formed by the Earth's magnetic field, which reverses polarity over time. When molten rock at mid-ocean ridges cools and solidifies, it records the direction of the magnetic field at that time. By studying these patterns, scientists can not only confirm the process of seafloor spreading, but also gain insights into the history of the Earth's magnetic field. As new oceanic crust is formed at mid-ocean ridges, it records the magnetic field's polarity at the time. This continuous process of crust formation and movement is a fundamental aspect of plate tectonics, driving the movement of continents and the reshaping of the Earth's surface over geological timescales. Understanding these processes not only helps us comprehend the past, but also allows us to predict future geological events, making the study of plate tectonics crucial for both science and society. Section 5. Shaping mountains and unleashing fury. Tectonic activity is responsible for some of Earth's most awe-inspiring geological features. The collision of continental plates can create towering mountain ranges, such as the Himalayas, which continue to rise today. Volcanoes, another spectacular manifestation of plate tectonics, occur at both divergent and convergent boundaries. They provide a window into Earth's interior, spewing molten rock, ash, and gases from deep within the planet. While tectonic activity can create breathtaking landscapes, it can also unleash devastating natural disasters. Earthquakes, tsunamis, and volcanic eruptions can cause widespread destruction and loss of life. Section 6. Exploring the depths of our planet. Understanding tectonic plates is crucial for predicting and mitigating the risks associated with natural disasters. Scientists use various methods to study plate tectonics, including seismology, geodesy, and remote sensing. Seismology is the study of earthquakes and the propagation of seismic waves through the Earth. By analyzing seismic waves, scientists can learn about the Earth's internal structure and the movement of tectonic plates. Geodesy uses GPS and other technologies to measure the precise movements of Earth's surface, providing valuable data on plate motion and deformation. Remote sensing techniques, such as satellite imagery, allow scientists to monitor volcanic activity and other tectonic processes from space. Section 7. Protecting our future on a restless Earth. As we continue to learn more about Earth's dynamic nature, it's essential to apply this knowledge to protect ourselves from the potential hazards of tectonic activity. Building codes in earthquake-prone areas, early warning systems for tsunamis, and volcano monitoring programs are just a few examples of how we can mitigate risks. By understanding the forces that shape our planet, we can better prepare for natural disasters and create a safer future for all. Let's continue to explore, learn, and work together to live in harmony with our restless Earth.